So this is the class opener we're doing today, and it's simply looking at these numbers, these real numbers, and classifying them. And we don't want to state all the groups they belong to. We just want to be as specific as possible. So you might need your notes, and here's the diagram we've been using. So here are the real numbers, and of course I mentioned imaginary numbers, the square root of negative numbers. Those are imaginary, but that's more like for Algebra 2. We're going to focus in on these real numbers. So once again, a quick review. Naturally, you learn how to count 1, 2, 3, 4. You grew up a little. You understood the concept of the number 0, the number with the biggest whole in it. That's why when you add 0 or when you include 0, it's called whole numbers. Then you grew up a little more and you realize that not only do you have positive numbers, but you also have negative numbers. And not only that, we also grew up a little bit more and realized that there is not always just nice numbers like 1, 2, 3 or -1, -2, -3, but you might end up with like -half or maybe 2.5 or maybe 0.75. So whenever you have decimals or fractions, which are ratios, we have the word ratio inside rational, then those fractions and decimals are called rational numbers. And we also know the word rational means that it makes sense, that you understand it. Like we all know what 3/4 of a pizza is, right? But irrational means numbers that are crazy decimals that continue on forever, that don't have a pattern and do not repeat. Now, if they do repeat, like the 0.252525, that looks crazy, but it's not really crazy because we could convert that to a fraction, 25/99. Anyway, irrational numbers are those crazy numbers, irrational, crazy numbers that have a decimal and that continue forever without a pattern or without repetition. Anyhow, number 1, when we think -2,355, is there a decimal? Is there a fraction? No, this is just a nice number and it's negative. Yeah, it's huge, but it's negative, so that would make it an integer. So number 1 is an integer. Let me do this. And the next number, 0, the number with the biggest whole in it, that makes it a whole number. Now number 3 might be tricky for some, because some people see the fraction and they think, oh, a fraction is a ratio, which makes it a rational number. But the problem is, yeah, it's rational, but you could be more specific. If we think about what this fraction actually is, it's a division problem, 12 divided by 6. 12 divided by 6 is the number 2. And when you classify the number 2, we know that that is a nice natural number. Looking at number 4. We have the fraction 4/6. You could reduce it, but even if you were to reduce it by 2, it'll become 2/3, and 2/3 is still a fraction. It's still a ratio, which means that it is a rational number. And again, emphasis on the word ratio inside rational. Number 5, if you were to do the square root of 36, the answer is 6. The square root of 25, the answer is 5. The square root of 30, if you do the square root of 30 on a calculator, it'll give you a crazy decimal that continues on forever, that doesn't have repetition, or it doesn't have a pattern. So right there we would say that it's crazy, which means it's an irrational number. Now number 6, it may seem crazy to you, but this line above the 238, it means that it's repeating 238, 238, 238. So it does go on forever, but is it crazy? Not that crazy. Why do I say it's not that crazy? Because it repeats. So believe it or not, we could convert that decimal, that ugly decimal, we could convert it to a fraction. Let me make some space to show you how to do that. So what you have to do, the trick is, and you don't have to know this, right? But it's a cool little math trick here. When you look at the numbers that are repeating, all right, the 238, that's what's repeating. And then if you think about the position of the numbers that it's in, now what do I mean by that, the position of the number that it's in? Well, we have the tenths position, and we have the hundredths position, and we have the thousandths position. So if I wanted to make a fraction that represents the decimal 0.238, I would simply put the 238 over the 1000. Now why is that? Because the last number is on the thousandths, okay? Now, if I did type this into a calculator, 238 divided by 1,000, the answer will be on the calculator 0.238, and that's it. It's not going to repeat. Now, as you see, it repeats up here, 238, 238, and this line means that it keeps going 238, 238. So the little math trick that I'm about to show you is you go to the denominator, the 1,000, and you subtract 1 from it, okay? Now that obviously is going to change it. So let me rewrite it over here. 238 over 999. 1,000 take away 1 is 999. Now if you do that on a calculator, you will see that it gives you 0.238, 238, 238. So that does repeat. Okay, so this last question right here, knowing how to do this is really not that necessary for this section of the class, but it's just a cool math trick. Anyway, the only way it's irrational is if the decimal does not repeat. If it goes on forever and it does not repeat. So right here, it did repeat, 238, 238, which means that it could be written as this blue fraction, 238 over 999, which means that that is a rational number, rational. Again, emphasis on ratio because we are able to write it as a fraction. So, all of that is just based on these first part of the notes that we've already covered yesterday. I hope this helps